In this video, we're going to talk about one of my all-time favorites, which is a cheat code for freefall problems. I don't know if you've ever been playing a video game before where the game was just too hard and you finally found a cheat code that allowed you to beat the game. We're going to bust out a cheat code for some of these problems, and that's known as the peek trick. In a way, the peek is actually the most interesting part of an object's flight because there's one thing that you'll always know for sure, and that's that its vertical velocity will be 0. When a ball's going up, it's getting slower, 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 and then it finally reaches the peak. Here, let me draw it for you. So if I have a ball like this, and as it's going up, it's getting slower, 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 gravity's pulling it down, and then finally it can't get any higher. Gravity's sucked all the velocity out of it. Well, that's when it's at its peak. And then at that exact moment, when it has no velocity left to take away, that's when it'll actually start getting fast again, because now gravity's going to make it go faster, faster, faster down. But the peak is a very interesting location because of this information, because we know that the object's neither going up nor down. It's changing directions. A second big point I want to make here is if the object ends up landing at the same height that you threw it from, then the amount of time that it spent going up to reach the peak will equal the amount of time that it spends going back down to the ground from that peak. Those two times are equal. The first half of the flight is spent going up, and the second half of the flight is spent going down. And that's a really, really cool shortcut for us. So what I'm going to do next is just rapid fire some problems for you to show you just how fast and awesome this cheat code is for some of these problems. So the first sample question is, a ball is thrown straight up at 30 meters per second. How long until it reaches the peak of its flight? So if I draw the ball's condition at the first second, right when it gets thrown, it's going upward at 30 meters per second. Exactly 1 second later, the ball got 10 meters per second slower, because that's what happens on all of these problems, right? Acceleration equals minus 10. So after 1 second, it went from a speed of 30 to a speed of 20. It got 10 slower in 1 second. If we go forward another second, then now it only has an upward velocity of 10. Gravity keeps sucking the speed out of it 10 at a time for every second that goes by. And now finally at the end of the problem, we arrive at the peak where it has no velocity left to take away. The amount of time that this entire thing took is, if at the bottom down here it was time equals 0, then this would be the snapshot where time equals 1, time equals 2, and time equals 3. So we would say that it takes 3 seconds for the ball to get to its peak in this particular problem. Some of you might have noticed that this was kind of a lot of work, and you actually could have taken a much quicker version. You could have just said, well, if I started with a speed of 30 meters per second, and every second that goes by, the ball gets 10 meters per second slower, then you just do 30 divided by 10 to find out that it takes 3 seconds for the thing to peak. And you would be correct as well. I just wanted to show it a little bit in case some people didn't see that. But in the future, we're just going to do it this way. We're going to say, look, if you're going up at a speed of 30, and gravity sucks out 10 every second, then it'll take you 3 seconds until there's nothing left to take. And when there's nothing left to take, then that's when you're at the peak of the flight. The next problem says, Justin Bieber is thrown straight up at 20 meters per second. How long until he hits the ground? This one's a little bit more tricky because it's not just asking how long it'll take till he peaks, but how long it'll take till he hits the ground. Well, since we already did this peak problem, I'm going to repeat kind of the same process here. Now, just like in the last problem, if he started out going 20 meters per second, and every second that goes by, he gets 10 meters per second slower, then the amount of time it takes till he has nothing left to take away is 2 seconds. It's just 20 divided by 10. So his peak time is 2 seconds. Well, I told you before that it spends the same amount of time going up as the amount of time that it spends going down. So if that's the case, then that means that he spent exactly 2 seconds coming back down. And if that's the case, then we know that the total amount of time he spent in the air was 4 seconds without any complicated formulas at all. In the next video, we're not just going to look at times and velocities, but we're going to actually measure how high and the object ends up going while it's flying. And that's much more interesting. And that's really why I showed you this peek trick in the first place. So stay tuned for the next one.